All right, I'm going to go ahead and get started. It's 3:01. For those in the audience who are Buckeye fans, the score is 23-14, Ohio State, fourth quarter. My name is Keith Wedinger. I'm a senior software engineer with Root Insurance, and I'll be talking about AWS Java Lambda functions with Kotlin. Here's our agenda. We'll go through a brief introduction. I'll give basically the AWS Lambda elevator pitch. I'll go through why you would want to choose Kotlin over Java. We'll go through a demo, first through the code, and then through the AWS console on how to deploy this and run your functions. And then at the very end, there's a slide with links, and there'll be plenty of time for questions at the end. But during the presentation, if you have a question, raise your hand, and I'll come to you and get your question answered during the talk. Before we get started, I've noticed in many talks that I've been to, people whip out their cameras and start taking pictures of every slide, or they're busily scribbling notes. You don't have to do that. Right here is the link to the slide deck and the links to the two GitHub repos. And so really, this is the only slide you need to take a picture of. I've also posted all of those links up on Twitter using the Ohio DevFest Twitter handle. I think everybody, okay, I'll give everybody a minute to either write that down or take a picture of it. Okay. A little about myself. Born and raised in Cincinnati, went to school right here at UC, graduated in '89. I've been a professional software developer for this is my 29th year. I've worked for several companies doing a wide range of projects. The list of companies are there. My very first project was writing x86 assembler to control a typewriter. My next assignment is going to be doing Ruby on Rails backend development with a React Native front end on iOS and Android. When I'm not working, I enjoy traveling and dining and craft beer exploration with my wife. And at this time, I'm going to get a gauge of who's in my audience. So developers, Java. Of those Java, are you using Kotlin yet? Couple, okay. .NET, web front end, and that's JavaScript or the myriad of frameworks. AWS, Azure. Wow, all the hands went down. Okay.
That's about right.
I'm sorry?
That's about right.
A little bit about the company. Root Insurance is a car insurance company, just like Geico and Progressive, formed back in 2015. They're based in Columbus. What differentiates us is that we use data science and technology to identify good drivers and then reward those good drivers with really competitive low rates. The whole premise is we try to eliminate that top 25 to 30% of those risky drivers that cause usually about 60% of the accidents. And we do all this through a mobile app. And so your entire interface with the company is through our mobile app. If you want more information about us, those are the two links above. You can also visit our booth downstairs where Chris Evans is more than happy to give you more information about the company. And yes, we are hiring. So why AWS Lambda? Here's the elevator pitch. Serverless computing, but what does that mean? I think that's a bad term because there is still a server there running your function. The big difference is you don't have to provision it yourself. When you run code using an AWS Lambda, you don't have to think about the servers. There's no provisioning. They basically perform all the administrative activities on your behalf. Lambdas only run when they're triggered, so there's not this continuous process chewing up cycles on Amazon and raising your bill. It only uses the compute resources needed, and so if you're running multiple instances of it or it requires more CPU or more power, it'll automatically scale up as needed. It'll also downscale and terminate the execution when the function is done. It's really nice is that it has pay-as-you-go pricing rounded to the nearest 100 millisecond. And what's really kind of nice for developers myself that are doing demos like this, they have a very generous free tier. So it allows developers to go out there, build Lambda functions, try things out for free. I just checked this a couple days ago, and this list is actually updated, and this is the updated list with regards to what you can use to build your Lambda functions. If you're using .NET Core, you can use C# or PowerShell. Go is new the last time I checked. They're still at Java 8. I suspect they'll move to Java 11 at some point because that's the next long-term supported release. If you want to use Node.js, you can use 4.3.6.1 or 8.1. And it also supports Python 2.6 and 3.6, 2.7 and 3.6. So why Kotlin? A little confession, when I proposed this talk originally, I didn't know this was going to work. I made the bet that because Kotlin is 100% compatible with Java, that I could use Kotlin to write an AWS function, and that proved to be the case. That, I think, is one of the biggest benefits of using Kotlin, is that you don't have to convert your existing Java code into Kotlin. You can mix and match them freely without any clever hacks to get the two to work together. Because at the base, they still compile down to a Java bytecode that runs in the JVM. So the two can live side by side. And let me give you a quick demo of that. Bear with me a second. Okay. Right here I have basically a credit card validation class. What it actually does is really kind of unimportant. The key to view here is that it's written in Java. Within this same project, I chose to write my tests using Kotlin. The two run seamlessly together. It didn't require any hackery or any clever tricks. I just need to organize my source code in the appropriate directory. So for instance, the Java source will go under source main Java. Kotlin code goes under source main Kotlin, and the same goes for the test directories. And so if we come up here and just run this thing, it's happy as a clam. It compiles down to the bytecode runs, and it doesn't matter that you've written it in Java or Kotlin. You can intermix the two. Another big benefit, at least in my eyes, is code brevity. The prime example is what I call data classes or entity classes. Typically in Java, when you're writing an entity or a data class, you got to declare your properties, you got to write your getters, you got to write your setters, you got to write toString, hash code, and all that boilerplate stuff every single time. Kotlin does away with all of that. Another thing that's coming in Kotlin 1.3 is JSON serialization analogous to what you get in JavaScript. And so you don't have to pre-declare your classes. The Kotlin runtime will take care of serializing, deserializing into objects, much like it does today in JavaScript. So let's take a look at code brevity for just a second. So here we have a video game class. And notice here we have properties up top, we have a constructor, we have a series of getters and setters. We have the equals function, we have the hash code function, we got a toString function. You're looking at roughly 74 lines of code. All of that in Kotlin boils down to line number 2. I don't know about you, I'd rather write that. When you put that data word on your class declaration, it declares that as a data class, and Kotlin generates all that boilerplate code for you for free. Some other things here to point out with regards to Kotlin. Property access is through dots, which is really kind of nice. Notice here that you can do string interpolation with a $ curly brace syntax, and anything that evaluates to a string can be put within those parentheses. So you can make a function call, you put variables in there, you can put properties in there, as long as that expression can resolve to a toString. You can do what is called named function arguments. I honestly haven't seen a really good use case for this. So basically what that allows you to do is reorder how you call the function. You can rearrange the parameters by using named parameters. Another thing that's really kind of nice is deconstruction. And so if you look at a line 15, we have basically a list of games, and we're going through a for each loop, iterating through that. As it goes through each one, it's deconstructing each instance into those 3 variables right there, and then you can use those 3 variables within the loop. Another big thing about Kotlin, and I think Java 11 does this now too, is type inference. So for instance here, I'm declaring a string constant and assigning it to string. Kotlin takes care of inferring that as the string data type. Now, Kotlin is strongly typed. So once you've done an assignment like this, you can't be assigning like an integer to a string. It's not going to coerce that type into something else. Once it's a string, it's always a string. And this last line is really kind of cool. Instead of running like if, basically what we're using here is that question mark to replace what you would typically do, like if x equals null, then this. If this equals x, then this. That shrinks down to this. So what's really happening here is we have a client object. If it's defined, it'll then dereference personal info, and if that's defined, then it'll return the email property. And if anything along those lines is undefined or null, it just simply returns null. Any questions so far? Okay. Reason number 3 for Kotlin, it has good ecosystem support. No surprise, JetBrains is the inventor of this language, so our IDE is the best to use when you're building Kotlin. Spring Framework 5.0 was the first release that basically treats Kotlin as a first-class citizen. And then if you're doing Android work, Google has come out and basically said Kotlin is a first-class citizen. So you can write your Android apps using Kotlin as opposed to Java, or you can mix the two. That is entirely up to you. Repeat the first part of that question, I'm sorry.
Do the other cloud providers support Kotlin?
They do because they're Java compatible. I have another talk where I talk about using Kotlin on Azure. And so I set the infrastructure up within Azure to do Java, and as long as it's bytecode, which Kotlin emits when you compile it, it's happy. That goes back to that 100% compatibility with Java.
I thought the Google Cloud Functions was Node only, Node.js.
I can't speak to Google. I don't know. I haven't done much work in the Google Cloud. It might be the case that they don't support Java yet.
I believe that's
Okay.
one of the downsides. Yeah.
Okay. But if they did, then Kotlin would be supported because Kotlin's 100% compatible. So how do I learn? The documentation for Kotlin is quite good at that URL right there. To their credit, JetBrains has put together what is called Kotlin Cones. It's a completely online IDE-like interface that allows you to experiment with the language. Don't have to download anything, don't have to install anything. You just run it right within your browser. I typically like to pick a project or a challenge and implement it in the new language. I use this right here. This is I event from code to pick up Kotlin every year around Christmas time. This website puts up a series of challenges and puzzles to work through, and that's actually a really good way to pick up a new language. So how do we do this? First, some prerequisites. If you want to use the command line interface, you can install it using that link above. There's support for Windows, Linux, and Mac OS. Underneath the covers, it does require Python, but the installers, you can either let the installer take installing Python for you, or if you follow the steps there, it gives you instructions on how to install Python first. For REST API testing, I'm a huge fan of Postman. It used to be the case that Postman was a Google Chrome extension. It's now its own standalone app, so it doesn't require Chrome, or you don't have to run it through the browser. For me, I'm typically working with multiple projects, and as a consequence, I'm using multiple versions of either Gradle, Kotlin, or Maven, and there's this tool called SDK Man that allows me to manage multiple versions and then designate which one is active at any particular point. Very useful, and actually you can use that to manage multiple Java versions as well. Within projects, I typically use a Gradle wrapper, and I'll show you what that means during our demo. And then I still don't understand, we're in it's what, 2018, and all your modern operating systems still don't have a clipboard manager built in. You get one clip. So I inevitably always install a clipboard manager of some kind. Mac OS, I think copy and paste is really very cool, and you're going to see me using that during the demo. So with that said, here's what we're going to walk through. We're going to implement our function using Kotlin, and I'll show you how to do that. There's AWS predefined interface that you need to implement. We'll build the deployment package. Then we'll go to the AWS console. We'll create our function. We'll create an execution role for it. We'll create a test for it, run the test. We'll upload it's part of that before we run it, of course. We'll upload the deployment package to AWS. We'll test the function. And as a bonus, I'll take you through the steps on how to wrap that function with a REST API within AWS. So with that said, let's go over to the code. And I apologize for the fuzziness. I tried to adjust the resolution, and unfortunately the display is just not very good. So I hope you guys can read this. So let's look at, hold on. I'm sorry? Well, let me try something. Is that better? Okay. Bear with me because I typically don't do presentation mode often. All right, there's test tracker. Hold on. I want that one. Okay. That should work. So basically, if you're going to implement an AWS Lambda function, you need to basically implement the request handler interface. That's the entry point that AWS is going to use to call your function. And so basically, request handler is going to take it's basically a templated class that takes a task request, and a task, at least for our case. Here, so basically I've defined a request handler that is going to accept a new task request and return a task. And so underneath the covers, what this function is going to do is take that new task request, which has like a date assigned to and a task description. It's going to wrap that and post it to an Azure app that I have running that's also running Kotlin. And so here we've defined our URL. What we need to do to allow that request to come in from AWS is implement handle requests. And notice here I'm overriding the function. Its input is the new task request, and the context is the AWS context. It's like information coming in from AWS so you can talk to it. And then in Kotlin, notice we define our return type by using the syntax :task. Built in, you get access to the AWS logger. So here we're creating a logger we're getting the logger from the AWS context, and that allows us to log stuff as the function is running. It's a very useful debugging tool. So really the function in of itself really doesn't do a whole lot. It's basically taking in a task request, logging that it's coming in, creates a new task, and then posts it. So the create new task function, it's pretty simple. You're going to create a due date, log that it's about to create a task, and then it returns it. And then really quick, let me get to, oh crap, okay. Bear with me a second. Let's go to task. And so here is what that task looked like. I've basically set up a data class, and I've defined its properties. So basically, it's going to have an ID, a name, a due date, and an assigned to. Pretty simple stuff. So let's go back to new task request. I've also created a data class for the new task request. And so what's going to happen is what we're going to post to our AWS function is a bit of JSON that represents a new task. And then there's code here that's going to, I basically am using the JSON library to parse that JSON into the data class. Let's go back to task. Oh. So here we create the new task, we do a post, and if you look down here, we've got our task. We create a JSON payload for it. We post it, and another library I'm using is KHTTP, which supports really simple HTTP communication. I'm going to post it to that URL. And then here is an interesting way to do a return. If you have an if-then-else block in Kotlin, and both blocks within that return a value, you can actually use this syntax called return if. And it'll basically return either what's coming back in this or what's coming back in this. Another one of those code brevity, code readability things that Kotlin has introduced. Any questions so far? Yes?
So the JSON stuff would be replaced in 1.3 with the
In 1.3, you will no longer need to bring in like that JSON library. You'll be able to use built-in JSON serialization, so you can get rid of that stuff.
Is it annotated like your Jackson would be or anything like that, or is it?
I'm not sure what it's based on. I think it wouldn't surprise me that they've based some of their work on those existing things, but it's not obvious that they're doing that because it's part of the Kotlin runtime. And so it's packaged as part of like the Kotlin jars. Oh, another point too, when you build your Kotlin apps, there is a slight overhead that you got to pay. If you're packaging jars, you got to bring in the Kotlin runtime jars. They weigh in around, I want to say 1 meg. It's not terrible. And I think there's a slight memory hit if you're doing Kotlin code. But I have not seen any performance difference between running Kotlin versus running Java. Side by side, they work just as well. So let's take a look at build.gradle. Come on. So basically to build a Kotlin app using Gradle, you need the Gradle plugin, which basically opens up the Kotlin compiler to Gradle. You still need to apply the Java plugin because at the end of the day, it's still going to be generating Java bytecode. And so really you only need at a minimum, you're going to need the Java plugin, you're going to need the Kotlin plugin. Some of the dependencies we bring in, there's the Kotlin standard lib. Right now, it targets JDK8 bytecode. It doesn't mean you can't use Java 11 as long as the resultant bytecode is Java 8 compatible. Here we bring in that Lambda core library that allows us, that opens up that interface that we have to implement. There's JSON and KHTP, the two libraries I brought in just to make my life a little bit easier with regards to processing JSON requests and posting via HTTP. And then here's just a couple of JUnit things. If you bring in this, I'm not going to cover it during this presentation, but there is a test class where I test all this functionality, and that's just your typical JUnit dependencies right there. The one thing I did have to add, this is weird. You would think if you support Java, they would support uploading a jar to run your AWS Lambda function. I think they might have fixed it, but I didn't want to mess with that prior to this demo. But when I originally wrote this, they require a zip file, which is weird. And so really what this is a custom task that builds basically what I call the Uber jar or Uber zip. What's happening underneath the covers is it unpacks all the dependency jars into the relative class files, packages all the class files into a zip file. So basically it's an all-encompassing zip that doesn't depend on any third-party jars running somewhere. It's self-contained basically. So with that, let's build this thing. I'm going to get out of presentation mode. And again, I apologize for the font, but really there's not much to see here because what I'm going to be running is just Gradle W clean build. One quick note about Gradle. Who here uses Gradle in their projects? Are you using the Gradle wrapper or an installed version of Gradle? Okay, real quick. You can configure your Gradle project such that it downloads Gradle as the first thing it does. And so it becomes self-encompassing. The developer doesn't have to download and install Gradle themselves. It's really kind of nice. And so that's what I'm running here is the Gradle wrapper to clean and build this thing. It's very fast. And if we look inside of distributions, and again, I apologize for the font, but there is our distribution package, package is zip. And if we were to take a quick look in there, let's do an unzip. Basically, it's all the class files that make up our project. Yes?
You
basically what I'm showing you here is basically all class files are then blown out and just repackaged as a single zip file. So let's go to AWS console. Let me do this. Is that better? Okay. First thing we want to create is our Lambda function. So we'll come down here, click on Lambda. We will create. We're going to author from scratch. Here is where that clipboard view is really cool for presentations. I've basically gone in here and pre-populated everything I need to do to run this demo, which is really kind of neat. But this is a tremendous time saver with regards to being able to move data between apps. So we're going to call our function Ohio DevFest Lambda FN. Here's those lists of runtimes we've already covered. We're going to use Java 8. One quick note, and I've done some Azure work. If you do something similar in Azure, they give you the choice of not only the Java version, but if they'll automatically patch it with the latest security patches, which is kind of nice. I'm guessing underneath the covers, Amazon's doing that. They just don't give you the option to opt in or opt out. We'll need a new role, so let's create a new role from a template. We're just going to call it execute DevFest function, and the role we want to use is this. It's not entirely obvious that that's what you need to choose to execute a function, but that's what you use. Basically, it allows that function to run within the AWS world. Come down here and we'll create it. Ah, yes, the beauty of doing demos over the internet. There we go. So, when you create your function, you automatically get the AWS Amazon CloudWatch log functionality for free, and you're going to see how that works with regards to the logger calls we put inside of our code. If we scroll down here, we're going to leave this alone because we're going to upload a zip. We're going to use the Java 8 runtime. Here is where we specify the name of that request handler that we wrote in our code. So basically, it's Lambda request handler. Oop, can't really see it. It's basically the fully qualified class name for our request handler. That provides AWS information as to what to call when this thing spins up. We will say upload, select our dist. Now, the default timeout is 15. I have found that 30 is more reliable. There have been a couple occasions where when it spun up this function, for whatever reason, it took longer than 15 seconds. I don't know why. I think it had to do with spinning up the JVM, plowing through all the class files, and then actually calling it. So save. As far as save, it's uploading that zip file. And so now let's create a test for our Lambda function. So we'll say configure test events. It's really kind of cool if your Lambda function handles JSON requests, rather than they default to this hello world template. And so basically all you need to do is replace the JSON that they put there with the JSON that makes sense for our Lambda function. And that's all we're going to do. So we'll come over here, new task request, and we'll replace this with the JSON incoming request. And so when we run this function through this test, it's going to post that JSON to our Lambda function. It's going to it'll take it, create the task object, post it to my Azure web app, and then get back a JSON response. So we say create. Everything's ready to go. I'm assuming I haven't missed anything. If we test this thing, voila. And they get full credit to Amazon. They give you this really nice interface to look at the results. And notice we made our post, and my web app is running on Azure, got the post, created a task, and sent back this response. The ID being an ID in the database column, the name of the task, the due date, and assigned to. So if we go to, I have my web app running on Azure, and so if we go over here, we just refresh it, there's the task we created. So basically that Lambda function created a post, posted it over to Azure, where I have the Kotlin Spring Boot app running. That processed the thing, added the task to the database that's running over there, and then sent back a JSON run, yeah, let's see this. Ah, there we go. Is that better? Yeah. You can also run that function from the command line, so let's do that now. So really, what I'm doing here is running the AWS CLI. I'm saying I want to invoke a Lambda. The invocation type is request response. There is our function name. The log type is tail, so it's basically going to return log output back to standard out. And here's our JSON payload, and then it's just using the default profile that I've already pre-configured on my Mac. So if we run it here, there's the log result that is base64 encoded. So if you were to take that and base64 decode it, you get a mirror of what was logged to the CloudWatch logs. And if we do a cat output file, there's the response. And if we go over here, we should see, yeah, there's the data that came in from the command line. Let's take a quick look at what goes in the logs. So anybody who's done Java work and are familiar with your typical loggers and they get logged in with all this like nice formatting and whatnot, this is a very, very similar feature within Amazon called CloudWatch. And so if we look at this, Amazon posted that. Here's our log messages that came from our code. There's the end request. And so this is a tremendously useful debugging tool when you're like running your AWS Lambda functions within the cloud. The logging is really quite good. You get it for free. So with that, any questions so far? Cool.
So is that running out in AWS now?
Yeah, my task tracker, it's running right there.
So could you just say it for posting?
We're gonna cover that. Okay. So let's look at, so now what I want to do is we're going to wrap this Lambda function with an AWS API. And so we can call the AWS Lambda function just choosing a simple REST API through Postman.
So the way it is now, you can only call it using the API.
You can call it, there is a variety of ways to call a Lambda function. You can do it through a command line, through scripting. You obviously can invoke it through here. There's various ways to tie it to other AWS services to kind of chain things together. And so it's basically, think of it as like a bit of functionality that doesn't need to run all the time, kind of a utility functionality. It should run relatively quickly. Anything that's considered like a long-running process requires more, something that needs to be more persistent, probably isn't applicable for Lambdas. But things like what I'm doing here where I'm just posting something to a service and getting a response back, that's very applicable. So really, I think where it makes a lot of sense is like in utility functionality, quick hits, all self-contained, doesn't have a lot of dependencies on other stuff. And actually, what you could do with this is you could do some orchestration, so you could write a set of Lambda functions, and when one finishes, you have some orchestration thing, gets the response, and then goes to the next one, and then gets the response, go to the next one. So there's a variety of use cases where they're applicable. But out of the gate, it doesn't provide a REST API. Wrapping it in a REST API is really simple. I'm going to show you that now. So what we need to do to create an API for this, we go to API Gateway, and we create an API. We'll give it a friendly name called Ohio DevFest API. We'll leave the description blank. And we'll implement the put method, because we're doing a put of a JSON request into our, Lambda function. Say put. Okay. And right out of the gate, you get a variety of options with regards to what you want to do with this API. And the default choice is Lambda, which is really kind of neat. What's really kind of cool is when you come down to this, you start typing, it auto-completes based on the Lambda functions I've already defined. It's kind of nice. We hit save, grant permission, and now we have put set. There's a couple things you need to do within the method request. I turn on validate body just to make sure our body's coming in. And then under request body, we're going to add a model, and this basically allows us to set application JSON as the type, and you just set it to empty. save it. Let's save. Now if we go back to like execution, now we can test this thing. So we go test. Right down here, we just need to provide a request body. Test. I believe it worked. Hold on. Yeah. Yep, there's a response. If we go over here, run this again, there's a result. And so there's one last thing we need to do after we created the API, you need to deploy it. When you deploy it, that's when it creates the URL. So if we come in here and say deploy, we'll use a new stage. And the stage, when I initially saw this, I wasn't sure. I don't know if stage is the right way to describe this. Basically what you're doing is creating the last part of the URL for executing this function. And they chose to use stage. So I guess stage kind of makes sense. You could have like a development API, a test API, and a production API. But here you can make the stage anything. So we'll just call it Ohio DevFest. We'll do a deploy. And right here it gives us the publicly accessible URL for accessing our API that'll access our Lambda function. Now obviously, if you're doing a production, you'd probably want to, and I'm not going to show this here, but there is a way to get that URL cleaned up. For the purposes of our demo, we're just going to use the one they gave us. So we'll say copy link address. And I have Postman already running, and let's see if I can get this to zoom out. Obviously not. Zoom in. Okay. So all we need to do is paste in our URL. I've already pre-configured this with the content type application JSON. Here's the body we're going to post, and if we click on send, there's the response. So everything's working. So now we've implemented a Kotlin Lambda function, we've deployed it, created a function for it, created an execution role so it can actually work. It's talking to a web app running on Azure, and we've wrapped it with an API that allows you to invoke it through just standard REST APIs. And if we take a look at Task Tracker, refresh that one more time, voila, it's there. Now this is a somewhat simple example of a Lambda function, but the key parts to take away is this. Kotlin's 100% compatible, so if you want to use Kotlin to implement this stuff, you can. You're not constrained to just using Java. Building this out is a simple matter of implementing that request handler, packaging it as a zip. As you can see through the console demo I gave, getting it into Amazon is very straightforward and very simple to set up. They provide a lot of useful functionality, not only test your functions, but to track how often it's been executed through the logs. So it's really, Amazon's done a really good job of making it very straightforward to build and deploy and run these things. Here is a set of helpful links that I encountered while building out this demonstration and the presentation. Again, there's the link to this presentation. The repos you're going to see, one of them is for the Lambda function itself. The other one is for the Task Tracker app that's running inside of Azure. So you get both pieces. So feel free to download those, fork them, use them however you wish. There's the try Kotlin URL. There's the Gradle URL. I didn't show it, but if you so choose, you could use Maven to build this thing. I used to be a Maven debutante until I got introduced to Gradle, and then I don't like Maven anymore. So Gradle is usually my build tool of choice in the Java and Kotlin world. Oh, and another thing too, and it just came out. I haven't used it yet. You can now use Kotlin to write your Gradle build files. You no longer have to use Groovy, which is kind of nice. And then there is the list of AWS Lambda function documentation links. Here it covers the first one is the introduction. Second one is the Java programming model. The third goes into implementing that predefined interface. And then the fourth one shows you how to package it into a zip and get it into AWS. Any questions? Yes?
So that AWS API that you set up pretty quick, is there any sort of security integration if you wanted to provide, like, have sort of a tokenized request or have some basic auth or in that? Is there?
Yes. I have purposely, for the purposes of keeping this more simplified, yes, you can put in all that auth stuff too and secure these things. And you can either do it through, how you do it depends upon your requirements. But yes, AWS gives you all that security stuff such that you can guard who actually accesses these functions.
Right.
And it can be done at the Lambda function level. It can be done at the API level. You could do it within your code. You can do a combination of all the three. It just depends on what your security requirements are. Yes?
Have you used this before, like a real-world example where you've used Lambda functions?
I'll be honest. I was curious to. I picked up Kotlin last year, and I was looking for. I was like, all right, where can I use this? And so, I haven't unfortunately had a job that requires me to use AWS Lambda functions, but that's about to change because I'm going to Root Insurance where they do everything on Amazon, and so this knowledge will transfer there. And so one of the challenges I had is, well, what do I build to demonstrate this? I didn't want to just do a simple hello world. I didn't see a whole lot of value in it. And then I thought to myself, well, wait a minute, I got this web app sitting over here. How about I build a way to post requests from A to B, which is somewhat useful. But real world, not yet. But I anticipate that's going to change very soon.
Yeah, I'm just thinking of, like, because with your example specifically, there is a backend that exists that it's talking to eventually. You know, I was just trying to think of, like, would you ever be completely Lambda functions, or would you always kind of want this?
Again, it depends on your requirements.
Right.
Yeah, I used to do a presentation called what mobile platform should you use? Hybrid, native, that sort of thing. And one of the first comments I made right out of the gate was, that's not an appropriate question at this point. Let's understand what you're trying to build first, and then we can choose the tools that make sense for the thing you're trying to build. Right. They make it very clear, and I think Azure has a similar type of functionality. This stuff is for those quick-hitting utility functions that don't have, clearly they have to be stateless, because once the function's done, it's done. If it needs to remember something, then it needs to persist something to a database, because once the function is done, it's done and over with. It doesn't remember invocation A to B to C to D or E. And so utility stuff like this I think is most applicable for that. But both Cloud and Azure do a good job of, if you have a function that's just getting a lot of requests, they'll spin up the cycles to do all those parallel executions if you want. Go ahead.
One of our clients uses AWS functions for integrations. So they generate some work that needs to go to a number of different systems.
Mm-hmm.
And so they have functions written so that they send in the data, and then the functions break it up, and this one talks to this system, this one talks to this one, this one talks to this one. And so it's kind of an integration layer.
Oh, that's interesting. So like you would call one Lambda function, that would trigger 6 Lambda functions that
Right.
would go out and talk in specific environments.
Right.
Yep. And I think and I think that's really applicable like in a batch, where there is no guarantee on how fast this thing's going to return. Now, that being said, based on my work I've done so far, it does turn around pretty fast. But I think, to your point, if you have that integration functionality and you need to go get all this stuff computed and you split it out across multiple Lambdas, as long as you're not time sensitive, as long as the stuff comes back in a reasonable time manner, I think that's a really good use case for that.
Cool. Good. Thanks.
Any other questions? Well, with that said, thank you very much. I appreciate your coming. And if you haven't done so, make sure to visit our sponsors, without which conferences like this are not possible.